Okay, chapter 3.6, converting measures. This is an important chapter, important section. You notice we've got length here, we've got capacity, and we've got weight. And the first example talks about capacity. Quarts, 1 quart equals 0.95 liters. Or, you see that little wiggly sign? Looks like this. It doesn't mean equals, it means approximately. So it's really 0.95 something, 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 but they round it up to 0.95. 1 quart is almost a liter. It says we need to convert 5 quarts, or 5 liters. So we're going to take 5 liters and we're going to change it to quarts. That makes sense? Okay, so we have to set this up. We're going to multiply by a factor of 1. So you're always going to multiply by 1. And this is super important. We always want to multiply by 1. The reason this is so important is because anytime we multiply by 1, we get the same answer. For instance, 3 times 2 halves is equal to 6 halves, which is still equal to 3, but 6 halves looks a little different than 3. We're just changing it, and when we multiply by 2 halves, we're really multiplying it by 1. So a lot of times we're going to find a different form of 1 to multiply things by, so that we get a different look to it, but it's still an equivalency. It's equal. They're still the same. So we're going to take 5 liters, and we're going to multiply by 1, but we're going to write 1 as a fraction. And over here it tells us that 1 quart is about the same as 0.5 liters. This is the important part. We're going to put that in here, but we're going to use it as a fraction. If they are equal, and we put them one above the other like we did up here with 2 halves, then they're still equal to 1. For instance, if I were to write, I'm looking for a place to write, I don't want to, if I write 2 plus 1 over 3, that's still equal to 1. So something on top is equal to something on the bottom means that it's equal to 1. So we've got 1 quart and we've got 0.595 liters. So we're going to write 1 quart and make a fraction with 0.95 liters. And the important part here is that we have to get the liters to be in the denominator, because the liters over here are in the numerator. Notice if I write this as 5 ones, it's still 5. But I have in the numerator liters and in the denominator liters. This is an important aspect because the liters actually cancel out. If they're on the same, they don't cancel out. But if they're opposite, 1 in the numerator and 1 in the denominator, then the liters over liters equals 1. And it leaves us with quarts. And we're trying to change something to quarts. When we change it to quarts, we want to get rid of the liters. So I could have set it up the other way where I put the liters on top, 0.95 over 1 quart, but we wouldn't have canceled out the liters, and it wouldn't have given us an answer that we would have been happy with. This way, when I write it, I have equals 5, or is about. I have to remember to say about approximately because I used an approximate measure here, so I'm not actually allowed to write an equal sign. I should say this is approximately 5 times 1, which is 5, over 1 times 0.95, which is 0.95. And I still have my quarts. Okay, so it's 5 over 95 quarts. And I just have to use a calculator to do that. And if you can see me do the calculator right here, I suppose. Let's clear this out. You should have a calculator as well. This is one of those places to use a calculator. So it's 5 divided by 0.95. And then equal. And you get 5.2631. It'll keep going. We can just stop right here at the 6. 5.26. They used 2 digits when they had it to begin with. And this 3 is a low number. If it were like a 9 or something, I might round this 6 up to a 7. But it's a low number, so we're going to leave it alone. So it's 5.26. And remember, it's about 5.26 quarts. So there were several important things here. We're going to multiply by 1. This is the most important thing. We're going to set it up so that the liters are on the top and the bottom so that they cancel out, leaving us the quarts. We had started off by wanting to take 5 liters and change them into quarts. 5 liters is the same as, approximately the same as 5.26 quarts. We can do this over and over, and that's what you're asked to do. You're asked to do like changing, number 1 on the example is changing 7 miles into kilometers. Well, let's change 6 miles into kilometers, and we can see by adding, let's see, add this back in and move it up to the top. There we go. That if we're changing miles to kilometers, that's this one right here. 1 mile is about 1.6 kilometers. So 1 mile is approximately 1.6 kilometers. So I set that up again. I'm changing 1 miles, and I'm going to multiply it by some factor of 1. I'm going to go ahead and put my 1 underneath here so that I have a fraction. I want to make sure that I have my miles in the denominator because I had my miles on the numerator, and I want them to cross out. That means that I'm just going to put in my 1 mile is about 1.6. I'm going to put that down here and put 1.6 km up here. It doesn't matter which one goes on the top or the bottom, and because they both equal, it will equal 1 because they are equal to each other, or approximately. But what we need to make sure that we have the miles on the denominator and the numerator so that they cancel out. If I change colors so you can see that, I think I like orange better, tangerine. I'm going to cross out miles, and that's going to leave me with kilometers. And again, I just do my math with an approximation sign instead of an equal sign. 6 times 1.6 over 1. So see how last time I had a division problem, this time I have a multiplication problem. 6 times 1.6. Let's clear this out. 6 times 1.6 is 9.6. I just have to remember that. So it's about 9.6 kilometers, because kilometers is what I have left. So if I know that there's more than 1 kilometer in every mile, I should recognize that when I change to kilometers, I'm going to get an answer that's bigger, because I'm changing to something that actually is smaller. Kilometers are smaller than miles a little bit, because if you run 1 mile, you actually will have run a little more than 1.5 kilometers, 1.6. So that's how that works. Let's use one more time. We'll use this, and because this job is actually kind of hard, and it might be that this video is longer than it should be, but I need you to understand it. This is a concept that's very important. Let's change 6 centimeters into inches. Oh, I didn't need to say into. I guess I can quick erase. I said into. I wrote an approximate sign, but I said into. So that's a little silly. We're going to change 6 centimeters into inches. We're going to look up here, and we're going to notice that 1 inch is about 2.54 centimeters. 1 inch is approximately 2.54 centimeters. That means it takes 2.5, almost 3 centimeters to make 1 inch. And I have 6 centimeters. I want to know how many inches that is. So I just start with 6 centimeters again, and I multiply by 1. Just like I keep telling you, we're multiplying by 1. And this is our 1. We just have to write this as a fraction and put it in our little fraction bar. So 6 over 1 is the same as, now what do you want me to put? What do you want me to put on top? The 1 inch or the 2.54 centimeters? I want you to think about that. Which one needs to go on the bottom? You're right, 2.54 needs to go on the bottom because it's centimeters, and we need them to cross out. They need to cancel centimeters, and these become 1 centimeter. Well, they become 1 centimeters over centimeters. And then 1 inch up here. Okay, so this became our fraction. And we just put it together approximately. We're going to cross out our centimeters, and that leaves us 6 times 1 over 2.54. And again, it's just long division. That's all it is at this point. So go back here. What did I say? 6 divided by 2.54. 6 divided by 2.54 is 2.3622222. We're going to stop at 2.36. We're not going to go on to that 2. So this is about 2.36. And it's about that because let's see, if it were 3 centimeters were equal to 1 inch and we have 6 inches, we'd have 2 centimeters, but it's a little less than that, so we have a little more than that. All right, nice job. I wonder if there's something else that you need to be able to do. There's one more thing, and I know this video is getting long. We're going to compare units and we're going to convert a rate. So we're going to convert 25 ounces and we're going to change it to kilograms, which is kg. Okay, and we need to understand that, so 25 ounces, we're going to multiply, see now this is ounces and kilograms, that there is 1 pound is 16 ounces, and it doesn't tell you that anywhere. It is in the back of your book. You can find it there if you need to. But 1 pound over 16 ounces. We do that because we want to make sure the ounces are on the opposite of those ounces, numerator and denominator, so we can cancel them out. I'm going to put it in. Move it up. Okay. So when we need to see real quickly, we're having pounds and kilograms here. But what they don't tell us is how many ounces are in a pound, and I know, and it's in your book. You'll just have to find it. So if we start over again, we're changing 25 ounces into kilograms. So we're multiplying 25 ounces times 1 pound over 16 ounces. This is the complicated part because there are 16 ounces in 1 pound. So that means that 16 ounces and 1 pound are the same, which is why they're 1. We always multiply by 1. Okay, so we've got that part figured out. Once we've done that, we need to figure out how many pounds are in kilograms, and that's up here to change it to kilograms. So I've gotten rid of my ounces, and now I need to get rid of my pounds. This is a 2-step, or you do it all at once, but we've got to put pounds in there. So we put the 1 pound on the bottom, because that matches the pounds there, and we can cancel them out. We could do it now if we wanted. And then we're going to put the 0.45 kgs, or kilograms, on the top. And we're going to go ahead and multiply all of these things together. And what that looks like is 25 times 1 times 0.45, which ends up being 25 times 0.45. My pen is not working. Okay, all over 1 times 16 times 1, which is all over 16. And again, we can use our calculator. 25 times 0.45, and this is my multiplication sign. We could put it with a parenthesis too. The book uses the dot, but I kind of like the parenthesis. 25 times 0.45 all over 16. So that means 25 times and then divided by 16. So let's see if we can remember this. 25 times 0.45 divided by 16. 25 times 0.45, and then hit equals, so that's 11.25 divided by 16, and you get 0.703, and we're just going to go 0.70 because we used 2 digits here, so we're going to keep 2 digits. And this is approximately 0.70. This was supposed to be approximately 2. And it's kilograms because we got rid of our ounces, we got rid of our pounds And this leaves us with, I didn't mark that, but that's what kilograms is, 0.45 kilograms. Okay, I know that's hard. You've got several to do, and I'll work with you if you come find me. The last one is converting a rate. We're going to convert 50 miles an hour to kilometers per hour. It's the same thing. We'll probably need this. This was in your book, by the way. You could find it on chapter 3.6. We're changing 50 miles an hour, and we're going to change it to kilometers per hour. So this per, it's like over. It's like 50 miles over 1 hour, okay, is the same as how many kilometers per hour. So we have to use our 1.6 kilometers, which is this one. So we're going to put our we're going to change the miles first. 1 mile, 1.6 kilometers in 1 mile. So 1 mile is 1.6 kilometers. Now we've got hours and kilometers, but we can live with that. What we're trying to get rid of is the miles, because we're changing it to kilometers. And then we just have to do 50 times 1.6. Do an approximation again, because what's approximately 50 times 1.6? How do I clear this? There we go. 50 times 1.6 is 80. Well, that's nice. It's a nice even number. I like that. And it's about 80 kilometers per 1 hour. So about 80 kilometers per hour. And you can write that 80 km per h, km/h, miles per hour. Okay? Now that was kind of quick, but I think you can, that's easier than that one. All right, we'll stop.